Hello and welcome to this video about simplifying radicals and fractions. So this video is sort of a continuation of simplifying radical expressions, but just focusing on when you have fractions, because that's something definitely new and something that a lot of students find tricky. So I'm just going to do three examples in which there are fractions, so that way you get several different looks at it, maybe have a better feel for how to work with radicals and fractions. First example I have here is the square root of 45 over 10. Now, the rule is that I could first of all simplify 45 over 10, so I'm going to do that. There's a common factor of 5 in there, and so I'm going to end up getting 9 over 2. So the rules of math still apply here. You know, you have a fraction 45 over 10, and someone said simplify that. Simplify it, but you're just doing it now under a radical. So now that we've done that, the next step is to take our radical and apply it to the numerator and the denominator. And there's a rule that allows us to do that. So we can now take the square root of the top, square root of the bottom. And when we do that, we end up getting 3 over square root of 2. Now, before you think you're done, there's another rule with radicals. You're not allowed to have a radical in the denominator. So you have to do what we call rationalizing the denominator. So I'm going to rewrite it down here on the left-hand side so I have a little more space to work with. In order to do that, you have to understand something about square roots. That when you multiply the square root of something by itself, you undo the square root. Now, you just can't randomly change the value of a denominator or a numerator, so if you do something to the bottom, you have to do it at the top as well. And so now we multiply these together, and in the top, we'll get 3 root 2, and on the bottom, we're left with just 2, because the square root of 2 times the square root of 2 is just 2. And so that's kind of a key idea with radicals. That when you multiply two of the same thing, you keep what's under the radical without the square root though. Alright, now let's look at one where you have to use the conjugate. And the conjugate is where you focus on this thing right here, and you're going to use the same numbers, 4 square root of 12, but now you're going to change the sign. Now, to make this maybe a little bit easier, I'm going to first of all simplify square root of, so I have 1 and then 4 plus, and since this is 4 times 3, I'll have 2 root 3. Now I'm going to think about using, or I will actually use the conjugate, and the conjugate is going to be 4 minus 2 root 3 in the denominator, and then you have to repeat that in the numerator as well. And then it becomes a big multiplication problem. So in the numerator, using the distributive property, and then down here, we have to use FOIL. So let's take a look at the numerator. Well, it's easy. We're just multiplying by 1. So 4 minus 2 root 3. Now here, let's take our time and really work on the whole FOILing process. So we have 4 times 4, which is 16. So that's first. Outside, 4 times 2 root 3 is going, negative 2 root 3 will be negative 8 root plus, now do the inside terms, 8 root 3, and then the outside terms, and this is where it gets tricky, sorry, not plus, it's going to be minus 4 times 3. And so, even though we have, we have to keep in mind, or be careful about multiplying the 2's and the 3's and keeping them separate. What can be under a radical, what can't be under a radical. Now, the reason why we use the conjugate is right here. These will always cancel each other out, leaving you with no more radicals in the denominator. And so we continue to simplify this. 4 minus 2 root 3 over 16 minus, and then do some multiplication. 4 times 3 is 12, and then we'll have 4 minus 2 root 3 over 4, and we can reduce these fractions to get, let's see here, 1, or actually let's go, so ways we can do this one. We could let it be 2 minus root 3 over 2, or we could say it's 1 minus root 3 over 2, like that. whatever floats your boat. They both mean the same thing, and both of them do not have a radical in the denominator, so they are both good to go. Let's do one more example of the conjugate, because again, it is a new concept and it is tricky. So square root of 10 cannot be reduced, so that is good right off the bat. Find the conjugate. The conjugate is 1 plus the square root of 10, and then 1 plus the square root of 10. Here I'll have to do a little more work with my distributing, because I have a 2 there. And so I will get 2 plus 2 root. The 2 and the 10, they do not interact. Like they are barred. This is a fence, this radical sign between them, and they're not allowed to interact. Beneath, now the shortcut to this, if you don't want to FOIL and write it all out, is just to know that you need to multiply this together and this. And so it'll be 1 times 1, which is 1, minus 10. And the thing is, this sign is always going to be negative. Always negative. Because these signs are going to be different. That's part of what the definition of a conjugate is. And so it's always going to be negative down there, so you've got to watch out for that. And now we'll get 2 plus 2 root 10 all over 1 minus 10, which is negative 9. And there we go. That's as far as we can take that one. So those are just a couple of examples of how to deal with radicals and fractions. Hopefully you found that useful. If not, and you still have some questions, please reach out to me, and I'm always willing to help.